Okay, thank you very much, Sam. Thank you for giving me the opportunity to talk about Brookhaven. It's my favorite subject to talk about. The history of Brookhaven is one of the most important stories of post-World War II science. It was one of the first 3 national laboratories. It was the only one whose mission was basic research. It was the product of a unique partnership between the federal government and universities, and it's been home to Nobel Prize-winning research 7 times. So I'm going to talk just a little bit about how it got here and some of its key instruments. It was a direct result of the jump in size and scale of science in World War II. Before World War II, most laboratories were small in universities or industries, but the war had a huge impact on science. Funding for science went up by an order of magnitude from $50 million to $500 million a year. The size of the scientific community also jumped by an order of magnitude. The huge new instruments were built, particularly, especially reactors. The World War II taught American physicists how to think big. And reactors were especially important because they created beams of neutrons that had been only available in small quantities before the war. Now you had whole beams of them, and but the reactors built in World War II were built in the center of the country, away from a potential German land invasion, and but most of the American Physical Society members lived in the Northeast. And one who grumbled particularly loudly was I. Rabi. Rabi liked to say that his was an American story, although it wasn't life on the Mississippi. He was born in the Austro-Hungarian Empire, and his native language was Yiddish. He wanted a reactor built in the Northeast, where most American physicists lived, but so did scientists at Harvard and MIT. And they went to General Leslie Groves, who was head of the Manhattan Project, because before, even though the war had ended, the Manhattan District was still in place, and he was in charge of the nation's atomic facilities. Groves said, you guys can have 1 reactor, not 2, so you have to get together. So 9 universities got together to create Associated Universities, Inc., and were approved to build 1 reactor. This was early in 1946, and incredibly, they managed to get the laboratory in place by the end of that year. It took a ferocious amount of work. One task was to choose a director. The first director was Philip Morse. The site was another problem. They needed a place to move into right away. And you know how impatient scientists are. That there wasn't time to build an infrastructure and roads and so forth. So in practice, that meant what they were looking for was a used army camp that was being decommissioned. A list of 17 was made, one by one. Here are the 17 proposals. Each university had a favorite. One by one, they dropped out. And a camp in the middle of Long Island won by attrition. It was built as an induction center. In World War I, Irving Berlin went there. Here's one of the first announcements. Here's what it looked like originally. You can see some traces of the original roads are still on site. It was, after World War I, it was taken down. Remember, that was the war to end all wars. But it was revived in World War II as an induction center. And at the end of World War II, it was in the middle of Long Island, in the middle of 2 abandoned muddy real estate projects, not near any of the universities. In fact, Yale is closer as the crow flies. I talked to one old scientist from Yale who said that the instructions for getting to the lab in the old days were take the Bridgeport ferry, go straight, left at the light. Rabi tried to make the scientists feel better by saying that the advantage of the site was that it's equally inaccessible to everybody. Norman Ramsey gave it the name Brookhaven, misleadingly suggesting shady trees and flowing streams. Here's the first story in the newspaper about it. Here's the early program. It was very ambitious, 5 departments, reactor program and accelerator program. Here's the scientists took over officially on January 1st, 1947. The first person on site was January 7th. Scientists began moving in March. This is the first, picture 1-1 in the lab archives. It was, as you can see, it's still an Army camp. Here's a picture of the early gate picture, and it was one of the first 3 national laboratories. So, historians of the future will look back on this as a key moment when research became not just done in one laboratory, but there were networks of different universities associated with the labs, and the labs were networks among themselves. And now, of course, it's a global enterprise. In the beginning, Oak Ridge was called Clinton National Laboratory, so the U.S. National Laboratory system was as easy as ABC. It was A&L, B&L, and CNL. Unfortunately, Oak Ridge changed its name and destroyed the pleasant acronym. Here's the director's office, very org chart. Morse left as soon as he could. He was a theorist, and he had government credentials. He wanted to get back to research. But the person who really built the lab in the early days was Leland Hayworth. Here's a picture with him and, as it happens, Maurice Goldhaber at the University of Illinois. He was the first, now the first generation of instruments. I'll mention a few of them. There were the graphite research reactor and accelerators. Here's the groundbreaking of the first reactor. Lyle Borst, who built the reactor, insisted on taking command of the actual machinery and scared a few of his fellow scientists, but it was a historic event. Here's part of the foundation. Here's a famous photograph. A reactor in those days was a big event, and it attracted the soon-to-be President Eisenhower. You can see Robbie over here. Hayworth is here, I think. They like to match up Gorinsky. Dave Gorinsky was one of the great Brookhaven engineers in the early days, because he was very short with Eisenhower, so with a lot of photographs where Eisenhower looks like he's towering over everybody. So this was at the groundbreaking. Here's the mock-up of the reactor, which should be someplace. It was the first peacetime reactor, and with an innovative design, and there's several features of it, one of which is the control rods came in from the side, leaving the most amount of faces for experimentation. These 2 faces, front and back, were for charging. The other faces were for experimentation, and top and bottom for experimentation too. Here's a beautiful photograph of it completed. It was incorporated into the logo of the lab. Now, the laboratory was also the subject of fascination in popular culture, as were reactors. If you were a geek in those days, this is what you'd read, astounding science fiction. Here's a picture of Brookhaven actually appearing on the cover of this science fiction magazine. Here's an ad for a movie about a nuclear reactor laboratory called Havenbrook, whose scientists saved the world from a rogue missile. But the reactors, born as they were in World War II, were the subject of concern and worry, and so they were associated almost instantly with radiation danger. And the early days, here's a story. There was always concern, and here's an interesting story where the reporter was at least responsible and took a Geiger counter out to check how much radiation was being released and found that there was not much. Here's the graphite reactor. The research was done at these pegboard-like holes. In the early days, atomic research was classified. But later, in Atoms for Peace, one side was classified, the other was not. They were separated by a big wall, which inevitably became known as the Iron Curtain. And it caused a little bit of problems. You had to have P clearance and Q clearance. That meant that you had bathrooms had to be P and Q, one for men or one for women, and this seemed ridiculous to a lot of scientists, and there were a lot of jokes. Urinals at B&L, for instance, were called P clearances. The graphite reactor made medical isotopes, which were put in things called rabbits, which were put in pneumatically into the reactor and out again directly to laboratories. Was there paperwork in those early years? Oh, yes, there was lots of it. They complained. This is the form you had to fill out in the early days if you wanted to do an experiment at the reactor. The Brookhaven graphic artist named George Cox designed the Atoms for Peace logo, which became incorporated into a stamp. Brookhaven played a role in the Atoms for Peace process. Also, George Cox, who was a very good artist, resulted in one of Brookhaven's several close encounters with celebrity, because for a short time he was the father-in-law of a Japanese artist named Yoko Ono, before she divorced his son to marry a British musician named John Lennon. There was an early accelerator program. Accelerators were different because while reactors produced one spectrum of neutrons, accelerators could be optimized to produce large numbers at different energy levels. The first director of the accelerator program was Stanley Livingston. At the low end, there was a 3.5 MeV accelerator. A Van de Graaff accelerator. It was inside this tank. It annoyingly developed a leak that only showed up when it was pressurized, so it was hard to pinpoint the leak. And Everett Hafner, who was a rather daredevil, decided to find it by clothing himself in scuba gear, having himself locked inside and partially decompressed, and spraying a helium sprayer over till they located the leak. He was a kind of daredevil. He was also a plane pilot. He died just a few years ago in a plane crash. There was a 60-inch cyclotron to produce heavier isotopes. A 240-inch synchrotron was planned, but it was canceled to make way for a much larger accelerator called the cyclotron. Here's a diagram of the magnets. Here's some pictures of the magnets. One of these, it had 288 of these C-shaped magnets, that one of which is outside the AGS building. Here's the first one being put into place. One of the great things in those days is that you could tell the government you were building this instrument and not quite know how you were going to finish it. So relying on technology that was being pioneered at just that moment, they didn't quite know how they were going to do the vacuum chamber. It couldn't be of metal because of eddy currents, so they tried to make it of at one moment of ceramic, but that didn't work. But it finally was made of thin pieces of metal covered by a rubber sheet, and here's people literally screwing it in the final stages. Here's what the cyclotron looked like just before it was cloaked with shielding, and here is it from the control room. Just as it was being finished, one of Brookhaven's accelerator builders noticed something funny. As the time went on, the accelerator technologies would be exhausted, but a new technology would replace it. And so people were wondering what was going to be the next technology new accelerator technology. Well, it was developed at Brookhaven called alternating the gradient, or strong focusing magnets, which allowed much more powerful accelerators with much smaller magnets. And that was important because magnets are the key element in accelerators. Was there paperwork at the Cosmotron? Yes, there was. This was the form you had to fill out if you wanted to do an experiment on an accelerator in those days. Meanwhile, the alternating gradient synchrotron was built using this new technology. I don't have time to talk about its experiments, but here's a team, at one of them at the 80-inch. You notice Ralph Shutt up here and Nick Samios down here. The other second-generation machines included the HFBR, which was based on another new idea that also originated at Brookhaven, the under-moderated core, and a second-generation Van de Graaff, the tandem Van de Graaff, was this one. A third-generation accelerator started to be built called Isabel. This story about this was so large that it was actually visible to space. I don't know if you could see it, but there's a Cheerio here. When one of the early Landsats was sent up, the Landsat, the NASA scientists noticed a little Cheerio in the middle of Long Island, called up Brookhaven to say, well, what is this landscape feature you've got there? It looks like a perfect circle. It was the new accelerator being built, and in a story I don't have time to tell now, but is a really great story that was transformed into the relativistic heavy ion collider, of which here were some of the first pictures. Yet another amazing development was of the National Synchrotron Light Source. I thought I had a photograph here, but I guess I don't. But Marty is going to tell about this. Here's the experimental floor. And something very interesting began to happen here. There was a massive and unprecedented flourishing of interdisciplinary research. And this is actually a diagram by former lab director Jack Marburger showing complexity is over here and scale is here, showing how in yet another Brookhaven innovation, you have the laboratory consists of several different facilities with overlapping regions within one overall research conceptions. Different instruments span different regions of both complexity and scale. So Brookhaven had an interesting evolution. It reinvented itself several times from a reactor laboratory to an accelerator laboratory to basic science. And one marker for this was, whenever eminent visitors came to the lab, they would get as a souvenir a little piece of something, usually a model of an accelerator magnet. But in 2006, that changed. This is what Samuel Bodeman got then, the Department of Energy Secretary. When he visited, he got a set of nanoparticles sealed inside a glass vase. So this new gift illustrates yet another one of Brookhaven's reinventions that is what has kept itself vital over all these years. Thank you very much.